So in this example, you're asked to differentiate a rational function here. Now I want to solve this a couple of different ways. Let me first take the most efficient route. So when we've got like a single term in the denominator like this, the most efficient way to approach this problem, in my point of view anyway, would be to divide each part of the numerator by x squared there in the denominator. So to rewrite this function as f of x equals, so if we divide, well, I'll write it out. Okay, so 2x cubed over x squared minus 4x squared over x squared and so on. 1 over x squared. Okay. And then simplify, rewrite from there. So first of all, the x cubed divided by x squared will leave us with 2x to the first. Here, I'll get a red marker to do some of this. So we cancel the x squared, we're left with x to the first. Here the x squareds just cancel, so we just have minus 4. Here, so we could cancel x in the numerator. This red isn't, it's kind of dried up. Cancel x to the first, that's going to leave x to the first in the denominator. This marker goes away. Okay, so we're left with x to the first in the denominator, which, okay, so when I'm writing it over here, to prep this for taking the derivative using the power rule, I'm going to write this 5 over x as 5x to the negative 1, because that's going to make it easier to take the derivative in the next step. And same idea here. So minus 1 over x squared, I'm going to write that as minus 1 times x to the negative 2. So this 1 over x squared right here is equal to x to the negative 2. This 5 over x right here is equal to 5x to the negative 1. And writing it in these forms here, like I said, makes it easier to take the derivative because we can just use the power rule. So now f prime of x, if we differentiate from here, in fact, here, I'll just write it directly underneath. F prime of x will be 2 times the derivative of x is 1, minus the derivative of a constant is 0. So that's, we just leave that off. Here, the negative 1 comes down, so this will be minus 5 x to the, take 1 away from the exponent, so that'll now be the negative 2 power. And then here the negative 2 comes down, so that's going to give me a coefficient of positive 2, with these two negatives turning into a positive. X to the, subtract 1 from the exponent here, so that's negative 3. Be real careful with those negative exponents. Make sure you subtract 1. So minus 1 will give us negative 3. And so another way to write this answer, I mean, it's best to write your answer without negative exponents. Try to rewrite, at least get rid of those negative exponents. So this will be 2 minus, so x to the negative 2, I'm going to put that back in the denominator as x squared. And same thing here. So 2x to the negative 3, so that would be x to the positive 3 in the denominator. So here's one way to write the derivative of that function. Here's our f prime of x. And again, I mean, you don't have to fully simplify, but it is best to write your answer without the negative exponents. Okay, another way we could have done that, if you just kind of blindly start this problem without thinking real carefully about the best approach, you might have used the quotient rule. And so that's a legitimate way to solve this problem. We could use the quotient rule, and I'm going to solve that way right now. So another way of working this, if I'm working from this function up here, then the derivative is the bottom function, so that's x squared, times the derivative of the top. So if I differentiate the numerator there, that'll be 6x squared, and then minus 8x to the first, plus 5 times 1, minus the derivative of that 1 is 0. And I see now the error, my way is going to run out of room here. Okay, but here's the bottom times derivative of the top, minus the top function, so we can just copy all that down, minus 4x squared plus 5x minus 1, times the derivative of the bottom, which is 2x. All over the bottom squared. And so one reason I want to do this, I mean, you see how much worse this is when we're working it out with the quotient rule. You are better off rewriting, dividing everything by x squared and just using power rule like I did to begin with. But I want to work this out. I want to show that this answer does actually match the answer we found there. So what can I do here to simplify? what I would do is, I see for sure I have a common factor of at least x to the first, because I have x to the first here and I have x squared here. I'm going to factor out x in the numerator. And so that's going to leave me in this first bit with x to the first times all of this, which I'll distribute that in the next step. And then if I factor out the x here, so I'm factoring out x to the first from each of these, then I'll be left with 2 times all this. I'm going to go ahead and distribute that 2. So 2 times each part of this. So that'll be minus 2 times this. That'll be 4x cubed. 2 times this. So that's, here, I need to be careful with my signs here. I'm not distributing this negative yet, so I'm going to leave this parentheses here. But I am distributing the 2 here. So 4x cubed minus 8x squared 10x, positive 10x, minus 2. Okay, I just want to be clear. So the x was factored out. The x is factored out here. The 2 is being distributed. The negative I'm leaving in front. I'll distribute that negative on the next step. Okay, so all of this over x squared squared, which would be x to the 4th. So now I can reduce, I can cancel this power of x here. I'm left with x cubed. Let's see if I can get it all written here at the bottom of the board now. Probably not, but okay. If I distribute the x here, so that'll be 6x cubed minus 8x squared plus 5x. Distribute the negative here. So that's minus 4x cubed positive 8x squared minus 10x plus 2, right? All over, seeing how this shows up for you guys, x cubed. This algebraic manipulation stuff, this is still good. I mean, I know maybe it feels tedious and beneath you at this point in calculus too, but it's important. I mean, these are important skills you don't want to lose. So let's finish this up. So 6x cubed minus 4x cubed would give us 2x cubed. So I'm just combining like terms now. Minus 8x squared plus 8x squared, so those cancel out. And that's it for the squared terms. Positive 5x minus 10x will give us minus 5x. And then all that's left is the plus 2. And this is all over x cubed. Now, let me point out, so we get this answer by using the quotient rule. Took a little bit of effort though. Notice with this answer here, and I know it's very densely cluttered here on my board, but compare these two answers. If I divided each part by x cubed, look at what you get. 2x cubed over x cubed, so that's 2. Minus 5x over x cubed, that'd be minus 5 over x squared. So that's good. Plus 2 over x cubed. So yes, we have the same answer, just written in 2 different forms. But taking a step back, yeah, that happened a lot quicker just by rewriting and using the power rule. So just keep that sort of stuff in mind. We want to take the most efficient approach.